In this video, we're going to talk about bias and the relationship between bias and variability when you are sampling. So, you're probably wondering if we're going to talk about something with statistics, why do we have this Google review of, and those of you not familiar with the area, you're probably wondering, how the heck do I say the name of this restaurant? And for those of you from the area, you either call it Zena or China. And either way you call it, it's pretty good food. If you look at the review, it's a 4.7 out of 5 and it has 584 reviews. This is a restaurant in Toms River. And it's the first restaurant I thought of because it's one of my favorites. And I wanted to go over just what a Google review is and how it does a good job of showing what bias can be. So bias is quite simply, it's when we have subjective information based on a personal preference that sways our opinion in one way or the other. Okay. You can have a political bias. You can have a bias towards, in this case, food. You can have a bias towards the way you learn in college. You can have a bias towards the type of cell phone you use, whether it's an iPhone or an Android. But one of the things that intrigues me is when you look at reviews, is to try and pick out how much subjective information is in a review. So at some point in your life, you are going to have to evaluate something or somebody. You're going to have to evaluate a procedure. You're going to have to evaluate a student. You're going to have to evaluate one of your employees. And when you do those evaluations or those assessments, you want to try and keep your evaluations tailored around objective things, right? So if I say, man, Timmy's a great worker, he's a wonderful person to work with, I give him a 5 star. It doesn't really do anything for me, right? Because that's my perception of him. Versus if I say Timmy increased his sales by 12.2% in the third quarter. Now I'm giving unbiased information that doesn't matter if you've known Timmy for 10 years or known him for 10 minutes. You can say, okay, he's been successful because he's increased his sales. So you can see, again, this has a pretty good rating of 4.7 out of 5. And it lists the nice 5 star ratings first, and these are great, excellent food, gigantic sushi rolls, one of the best restaurants around. These are all well and good. We're going to flip gears a little bit. We're going to go down to the lowest ranking, okay? Because even a 4.7 restaurant is going to have a very low rating from at least a couple people. And what you're going to see is these ratings are biased. Well, not the first one. Okay, this one says that suddenly there were roaches that appeared on the table. That's not going to change me going back. I'm still going to go back. But let's go down a little bit to I don't know. Let's click on let's read this one from Nick Sheridan. Okay, you have got to be kidding me. This is the second time I made a reservation. Only show up and have them say, "Oh yes, hello. Will be another 30 minutes." What's the point of a reservation? 2 question marks. Okay, so this really got to Nicholas, and you can tell he gave it a 1 out of 5. Okay. Now, objective, unbiased review here would be the fact that he shared that he waited for 30 minutes for his reservation. Okay. Now, the bias in that, for some people, that might knock it from a 5 star down to a 4. For some people, it might say, you know what, we still enjoyed being there, even though we were there a little bit later. They had a good ambiance. The host was great. We went to the bar, whatever, and we still gave it a 5 star. For Nicholas, he is biased towards punctuality, right? That means everything to him. That's why he gave it a 1 out of 5. He could have gone in there and had the best dinner of his life, but the fact that he had to wait 30 minutes for his reservation leads me to believe that he really values that punctuality aspect. Doesn't make it right or wrong, but it makes it a biased view. Okay, so again, with statistics, we want to try and remain as unbiased as possible. Here's another bias. Okay, is Nicholas a negative guy? Right. The reason I'm highlighting him is because he has 9 reviews. Right. Some of these other people have 20. It's a nice number to work with. And the cool thing about Google is now, or creepy thing about Google, whatever way you want to look at it, I can now click on this and I can see things that he's reviewed in the area. So I'm going to do that. Okay. And I want to see if there's a tendency of him to review things 1 out of 5. Okay. And it doesn't look so, right? He's got a 5 out of 5 here, a 5 out of 5 here. a 1 out of 5 here, 5 out of 5 here, 2 out of 5, 5 out of 5, 1 out of 5, 5 out of 5, 5, 5, 5, and then a 2. All right, and then it looks like he has a 3 here, a 2 here. What's funny is, though, the majority of his ratings are either a 5 or a 1, which is another bias in and of itself, right? We're more inclined to leave feedback or to give an evaluation on something where we had a really good experience, an awesome experience, or a really bad experience, right? Because when you think about it, a 5 out of 5, like everything about that was perfect, and there's a lot of places in this world where it's difficult to get, a 5 out of 5. All right, but again, reviews tend to show that bias. So with that being said, I'm just going to jump back to a couple of the slides that your author gives. I thought were pretty beneficial to look at here. And here's another working definition of what bias is going to be. It's consistent, repeated deviation of the sample statistic from the population parameter in the same direction when we take many samples. All right. Variability, again, as we described in the first video, this describes how spread out the values of the sample statistic are when we take many samples. Large variability means that the result of sampling is not repeatable. Okay? Good sampling method has both small bias and small variability. Now, the influence on variability is all about your sample size. The bigger that sample size, the smaller my variability is going to be. Okay? Bias, on the other hand, is purely dependent on randomness. Okay? If I can ensure that I'm selecting my samples randomly, I'm going to never eliminate bias, but I'm going to reduce bias. Okay? I love this visual here because I think it shows a good idea of how any 4 samples, or I should say the 4 options for any sample you have. Okay, the first one up here represents a sample that has small variability, meaning that we probably had a very large sample size, maybe it's 100 people, but there's also a large bias, meaning that we didn't select our people randomly. We selected 100 people from the university, but those 100 people happen to be the students in my statistics classes. Okay, convenient for me, but not very random. They're all mostly freshmen. They are students who can come to class at night, and they're all kind of hanging out in this region over here. Not a great way to sample, all right? On the other hand, let's say we selected students randomly, okay? So now instead of the students just from my classes, I pull a roster of all the students at TCNJ, and I randomly select them. So now I have a small bias. The problem is I have big variability here because I only selected, let's say, 10 people. All right? Instead of a sample size of 100, I'm only selecting 10. Okay? Not a great way to sample. Okay? C here, this one's the worst, right? It takes into consideration of both the problems in A and B, and let's just talk about this for a minute. A large bias, okay? Go back to the first example. I'm sampling people just from my statistics classes that are convenient for me, and then a large variability. Instead of selecting 100 people, I only select 10. All right, so I'm not really doing much work. All right, the lazier you are, the more variable and the more biased you're really going to be. That's another way to think about it. Okay, the more time I put into my sampling design, right? I pull the whole roster of every student at TCNJ. I randomly select. Okay, and now instead of 10, I randomly select 100. Right, it takes more time, a little more work, a little more care. But now I'm hanging around and hovering around that bullseye. Okay. Notice even with this, it's not perfect. It never is going to be. Okay. You still see some differences here. There's a little bit of variability. And if you really wanted to, I guess, point fingers, you could say there's a small bias here, right? Towards the north end of this bullseye, right? There's nothing really down here. Again, you're splitting hairs, but the point is you're never going to eliminate bias. And again, what's dependent on bias for sampling? You want to make sure it's random, okay? If it is random, then you're going to reduce bias. For variability, purely dependent on the sample size. If it's a larger sample, you're going to reduce variability.